Hi, this is Miss Litton. Okay. Hi, this is Miss Litton, and this is my period 4 honors bio class. Say hi. Hi. All right, and this is chapter 20, the endocrine system, and we're going to start right away with a question. And because we don't have themes anymore because of the clickers, would you please log in as your favorite movie character? That's appropriate. Your favorite movie character. We need to create themes. You know, you could be Birds of Oak Park, but I don't know if you would remember.
I mean, that is the best character of all time, just saying.
I'm just saying, I agree with you.
Yeah.
Super cool. John Wick. I haven't seen the new one. Is it just as good as the first one, or?
Yeah.
Well, the action was incredible. The fights. Jack Sparrow. Oh, Ron Burgundy. I love you. Whoever.
Oh my God. Who did that?
That's awesome. Star-Lord. Okay, you got one question right here.
Oh no.
Sorry, I probably should have paused through this part. I'll pause you. I'll pause you now. I'm pausing you now. All right, so here we go. See how you did? Oh, okay, come back to me. This is key. This is key for the endocrine system. They are ductless. So if they're not secreting into a duct like an exocrine gland would, an endocrine gland secretes into your, where in your body? Into your blood. Yeah, it secretes into your blood. Okay. So when we talk about the endocrine system, if you look here, the purpose of the endocrine system is to coordinate the activities of your body along with your nervous system. You could write that right at the top. You could add that in on your group shared notes up at the top where it says the endocrine system and hormones. It coordinates the activities of the body along with the nervous system. Who do you think is faster, the nervous system or the endocrine system? You're right, yeah. So it does work with the nervous system on that, and we're going to look at the overlap of that in the hypothalamus and pituitary gland in just a minute. Oh, yes, I can. Sorry. So, if the endocrine system secretes into your blood, could you please remind me what are the formed elements in your blood? Formed elements. Red blood cells, which do what? Stop eating in class. Red blood cells do what?
Bring oxygen to your blood.
Bring oxygen. What's another one?
White
blood cells. What do they do? Fight infections. What's your third one? Platelets. What are they about? Clotting. Those are your formed elements. Red blood cells, white blood cells, and platelets sit in the liquid part of blood. The liquid part of blood is called plasma. Now, let's remember what's dissolved in your plasma. Don't race it, just do it with me. What's dissolved into plasma? Gases, nutrients, proteins, salts, nitrogenous waste, hormones, vitamins. These are the hormones. So you'll never forget that. The hormones were put into your blood by your endocrine glands. Here they are. And we're going to know them all and love them. So how does it work that you could have a gland in one part of your body affect a target tissue in a totally different place in your body? How does it work? Anybody give a go on that one? How is it that I can have a gland here in my brain, like my pituitary gland, and it can affect some other gland in my body, like my thyroid? Yes?
Put it into the blood and then goes through the blood vessels throughout the body, and then wherever it recepts to something.
That's what he said. Wherever you have what? Receptor. So different tissues have different receptors, and that's how you can put something everywhere in your body, but it only affects some cells. So if I wanted to, right, I could use my phone to call out, but if I'm calling Tyler, only Tyler's phone has the what? receptor to answer that phone call. Okay? So it's the same way. You get it out, it goes out at the capillaries. What pushes this hormone out to these tissues out here? What pressure? Starts with an H. Hydrostatic pressure created by your what? Heart. And it's pushing that out with all the fluid portion of the blood out and around these cells. And whoever has a receptor, that's where it will bind and trigger a response. So on your notes, go to introduction. Hormones defined. Chemicals that affect the behavior of other glands or tissues. Chemicals that affect the behavior of other glands or tissues. Blue, tell them what hormones influence.
Metabolism, cells, growth and development of body parts, homeostasis.
Okay, and then endocrine glands. Guys, as soon as I start, you have to stop. You know that. Endocrine glands secrete hormones into the bloodstream. Perfect. The blood into the bloodstream, not ducts. All right, so nervous and endocrine system are both going to work to maintain homeostasis in our body. Work a little bit different. So we're seeing an endocrine cell from a gland secreting into the blood. Blood carries it. It gets picked up by a target cell. Go all the way to the other side, neurons. Neurons are the type of cell you find in the nervous system, but they are, instead of it just going everywhere like a hormone would in the body, it goes just to its target cell, and they are so close together. There is a tiny itty-bitty space. You could not see it with your eye. It's a tiny, tiny itty-bitty space between two neurons called the synaptic cleft. So it's called a neurotransmitter, not a hormone. It's still a chemical, but it's referred to as a neurotransmitter. Gets released by one neuron, and it has this one target, whatever it's synapsing with. That's how the nervous system works. In betweener, right here, these are kind of interesting cells. They're not just neurons, they're called neurosecretory cells. They act like a neuron, but they secrete a hormone. So it's a crossover, okay? It's kind of like the nervous system, it's kind of like an endocrine cell. It secretes a hormone which carried by the blood to a usually very close target. And the example we're going to look at here is the hypothalamus gland and the pituitary gland. So we'll be talking about nervous and endocrine, and so I want you to ping pong back and forth. Slate, you're going to be the nervous system. Blue, yes, I found ping pong paddles that matched. You're going to be the endocrine system. Go back and forth and say, I'm the nervous system, and go through each of these. Go.
Nervous system. I'm the nervous system. Sure.
All right, so on your notes, the endocrine system compared to the nervous system, the endocrine system acts more, what's the word you want there, quickly or slowly? Endocrine system works slowly. But the effect is longer lasting. Perfect. But the effect is longer lasting. Have you ever drank a Coke and eaten a donut or something super sugary and you feel a little funky, a little wired? Do you know what I'm talking about? So those are chemicals in your body. You're putting a lot of sugar in your body mixed with some caffeine. It can weird you out a little bit. You can feel not as good. Okay, so you're putting chemicals in your body and they're cruising around. How is this controlled? How is that regulated? And we're going to look at 3 different ways. 2 of them are positive and negative feedback. If I say, as a teacher, I'm giving you positive feedback, what would be an example of positive feedback? You did very well. What do you think, why am I saying that? Why would I give you positive feedback? What? So you'll what? You'll do better, you'll do it again. I'm encouraging that behavior. I am saying, good job, Jacob, okay? And hopefully then Jacob goes, yay, I want to do it again, okay? So that's the motivator behind positive feedback. What would be negative feedback? Do something wrong, and what would I say?
Bad.
You did bad. Okay. Yeah. That's what I would say. You did bad. Okay. Now, when I call you out with negative feedback, what is that hoping to do?
So you don't do it again.
Change your behavior, correct your behavior. Both positive and negative feedback are used in the body with chemicals. I don't want you to, the reason why I brought that up is I don't want you to put like things onto it like it's good or bad, like we use for behavior, correcting behavior or controlling behavior. And Slate's going to tell you why. Go ahead, Slate. Talk to him about positive and negative feedback.
We could switch. Okay. Both of these bring the body back to homeostasis. Negative feedback is getting the body back to normal. There are many examples.
So a negative is a shape of.
Now, in parenting books, they tell you for every negative thing you say to your child, you should say 10 positive things. Is that how it is in your home? If your parents say one negative, do they counteract that with the other way around? And you know what? And you know what I'm going to tell you? How probably what you experience as, with your parents is how it is in your body. There's way more negative feedback than there is positive feedback. Okay? Blue, here's another example. Go ahead and talk about this, Blue.
So what happens? Feedback, you get positive.
So it's just
Okay, so I want to focus on this one, the body temperature one. I'll give you a real example here. So if we start right here, your body temperature rises. Let's say you're working out or you're nervous or something like this and your body temperature rises. So you have sensors that detect body temperature is elevated. It sends a message. It sends messages to your blood vessels to dilate, to kind of bring that blood more exposed to maybe the surface of your skin in order to cool you off. Your sweat glands start secreting to put water on your skin, because we know water has a high, what? Do you remember? Heat, what? Remember high heat capacity? That's why you sweat. Remember when we talked about the properties of water? And so water can take that energy, that heat energy, that thermal energy out of your body and absorb it, and it'll absorb enough until it does what off of your body? Evaporates. Exactly, it'll take in that energy, and that's why the water cools you off. So as a result of your body going back to normal temperature, then you're okay. You don't need to continue on this it's corrected. And negative feedback is a lot. Do you guys know what cruise control is on a car?
Yeah.
So if I set my cruise control at 65, if I set my cruise control at 65 and I started going down a hill, what might my car be starting to do? Speed up. So the brakes will automatically get applied to keep me at 65. But if I end up going up a hill, my car will automatically need to put on some gas to make sure I stay at 65. And that's what negative feedback is in your body. It's keeping it at one normal level in order to maintain what? Homeostasis. That's why you see more negative feedback than positive feedback. Because positive feedback, it's amping and amping and amping it up to an ever-increasing level. Okay, so on your notes for negative feedback, the more gets you less. The level of the hormone itself or of some chemical induced by the hormone inhibits the further secretion of that hormone. Okay, then I put two examples in there. If you don't know already, anybody know what TH stands for? It's thyroid hormone. And TSH stands for thyroid stimulating hormone. Later when I teach you those hormones, we're going to come back to this spot if you want to mark it. This is where you're going to want to put in a picture that I show you later. There's going to be a picture for this, okay, that you'll want to grab and put in that spot. So I'll come back to that again. So anyway, it keeps you at a set point. Another way it can be controlled is through antagonistic hormones. And that is exactly as it sounds, antagonistic. You already know, what does insulin do to your blood sugar level? Lowers it. Glucagon will, raise it. You learned in your ed puzzle last night that calcitonin from your thyroid gland lowers blood calcium levels. I always remember it because calcitone it down now. And so it lowers blood calcium, whereas parathyroid hormone from your parathyroid gland that sits on top of your thyroid gland will elevate blood calcium levels. So they keep it just right. Exactly. So contrary hormones, antagonistic hormones, I believe the word you're looking for in your notes is contrary. Contrary hormones that have opposite effects. Okay, good, I started. Okay, let's look at an example of positive feedback. There aren't too many in the body. One of them, though, is childbirth. Okay? So, yay. Okay, no, whoops, I slipped and fell on a penis. This comes much later in life. Your uterus, if you have one, will contract. Super fun. And it pushes the baby's head against your cervix. And your cervix detects that, and it sends nerve impulses to your brain to let you know that your cervix is getting pushed on. Okay? That will then have your posterior pituitary will secrete more oxytocin, and oxytocin will make your uterus contract even more, which pushes more against your cervix, which comes back, and even more oxytocin, push more, push more, push more until the baby comes out. Okay? So this is amplifying, 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 amplifying for a purpose, to trigger something else, like the baby getting born. This is one of the hormones you're going to need to learn in just a little bit, so let's learn it right now. Oxytocin makes your what contract? Uterus contracts, so a baby comes out. I'm going to tell you something else because you can learn it right now. When that baby comes out, what are you going to have to do? Yes, you will have to hold it. You'll have to feed it. Okay? So what would be the natural process to feed that baby? Breastfeed. Okay? Oxytocin also makes milk come out. Okay? So it does both of it. It makes the baby come out and it makes the milk come out. It's the out hormone. So you can remember it like this, oxytocin. And you like scream it because you're pushing that baby out and then you got to feed it with milk. Okay? I'm going to tell you there's little differences. Okay? How many breasts do you have? Two. So you have two hormones that deal with them. One hormone makes the milk come out. A different hormone called prolactin makes you make the milk. Two different hormones. One makes the milk, so it's always on hand. And you can tell when your milk comes in, your breasts become as hard as rocks. It's like you have two rocks that you're carrying around that want to get out of your body. That's how it feels when your milk comes in. Okay? What makes the milk go out? What hormone makes it go out? Oxytocin. Prolactin from your anterior pituitary gland makes you make milk. How are you going to remember that? Prolactin. What does that sound like? Lactose. Exactly. All right, so there. Now you already know two hormones. Blue tells Slate the two hormones you know. Go.
You can describe it. You can describe it. What are the two most?
Okay, so now come back to me. Positive feedback, more gets you more. More gets you more. An ever greater change in the same direction. More gets you more. An ever greater change in the same direction occurs until a cutoff point is reached. Now, underneath malfunctions, I have a malfunction. Can you find the malfunction under malfunctions? They're both the same word. Okay? So keep the first one the same. This is a malfunction that can happen. Hypersecretion is too much.
I can't see.
And then change your second word to what?
Hypo.
Hyposecretion is too little. Okay, I'm going to teach you another hormone. You try and guess what it does. Ready? Growth hormone. Right. What could happen if you hypersecreted growth hormone?
Grow too tall.
Grow too tall.
Oh, like that guy.
Yeah. What happens if you hyposecrete it?
You don't.
There you go. So now you know three hormones. Okay? You got them now. You got three. All right. So, hyper is too much, hypo is too little. Now, the way hormones act depend on what the hormone is made out of. Most of your hormones are protein hormones. Some of your hormones are steroid hormones, but most are protein hormones. Proteins are water soluble. They dissolve in your plasma, no problem. But remember, what did we say about cell membranes? As far as crossing it, if you are large or charged, you can't go through. And this is true of protein hormones. They are large and they are charged. Yes?
So is that why it says peptide, because of peptide bonds?
Yes, that is why. It's another name that they're referred to as a peptide. Yes, polypeptide, perfect. See how smart you guys are? So, water-soluble hormones or protein hormones, they can't go through the phospholipid bilayer. They have to stay on the other side of the membrane. So what they do is they bind to a what? A receptor. That receptor may trigger in the inside, I'm not doing that to be mean to you, may trigger on the inside a series of reactions where this triggers this, triggers this, triggers this, triggers this. That's one way. Or sometimes what that receptor does is it opens up a gate and allows another, something like calcium, to come in. So it's the first hormone, and it triggers, the hormone is the first messenger. Whatever it triggers on the inside, or if it lets something like calcium come in, that's called the second messenger. So with protein or peptide hormones, if you look at your notes, peptide hormones are water soluble, and they work with second messengers. Now, if you look at this picture, here you can see this, and this is key. This is called a signal transduction pathway. So this is triggering this, is triggering this, is triggering this. What it ultimately might have is, and usually it does, some cytoplasmic response. Oftentimes, it just makes a bunch of sugar available for that cell. Now, if a bunch of sugar is available for that cell, what is it going to be able to do more of? You know the answer to this. Yeah, cellular respiration. If it does more cellular respiration, what is it going to have more of in that cell? Energy to do whatever it is that machinery does. Okay? So this process can be the same in most cells. What's different is the receptor. So the same metabolic pathways occur in all cells. Right, but what triggers that metabolic pathway depends on the receptor. What triggers that receptor? A what? Hormone. Do you see that? So there's redundancy there. That is conserved. That process, that metabolic pathway is the same, but what triggers that metabolic pathway is different. It can also impact gene regulation, but more often than not, protein or peptide hormones trigger some sort of thing within the cytoplasm. Steroid hormones are different, though. Steroids are, what category do steroids fall under? Lipids. Lipids are soluble into other lipids. So they can come right through the cell membrane, and their receptor is inside. It might be inside the cytoplasm, or it may not bind to something until it's all the way into the nucleus. And then it affects gene expression and what proteins are made. Its effects are slower. Steroid hormones are slower, but usually their effects, what do you know about slower acting things? They're more what? Long lasting. Okay, so between these two, peptide hormones are faster and steroid hormones are slower. So on the notes for that one, you're looking for in 2B, it activates a gene, and ultimately a protein is formed. Okay, I would like Slate to be the expert on the peptide hormones, and I would like Blue to be the expert in the steroid hormones over here. So Slate, Blue, here's another picture showing you the same thing. Go for it.
You can go. And then after the session, like yes, then they can go.
Okay, now, whoever this belongs to, you explain this. This is a super typical one for this particular category of hormone. Go ahead. Is that a peptide one or a steroid one? Okay, so go ahead, peptide person. I think that's slate, right? Go. Yeah.
It like
So if there was some electric field around your room and your mother could never enter your room, but she could see inside of it if the door was open. So she comes and she tells you before you go out, you have to what your room. All right, so this would be her standing at the door going, you better clean your room. Okay, and then this is the metabolic activity you have going on in your room. You would clean your room. Then when you open that door and show her that your room is clean, she would stop yelling. Does that make sense to you? So she's triggering something that's going on inside that cell. Now another thing that can happen is you could have it bind and then it could open up some gate that would open and allow a secondary messenger like calcium or something to come in. And then it could trigger a reaction. This too could be a second messenger. All right, here we go.
someone named himself Birds of Hope.
Well, we know who that was. CT. Cameron.
My computer.
I think, do you have it logged in on your phone too, babe? Is that a possibility?
What, me?
Yeah.
No. No, but like, not like the internet's working. Not working.
It's not lucky.
Tell her it's from. Okay, you almost done? 83% of you, unless you're logged in on 2 devices. Anybody logged in on 2 devices? Okay, I'm done waiting. Oh, we almost got 100. Yes, peptide hormones are received by a receptor located in the plasma membrane. Something inside the cytoplasm. What kind of hormone is that if it's received inside? Steroid. Look at your BioBuddies clicker. Darn it, that's going to take a long time. Look at their screen at their smart lab. Yeah. Praise or chastisement. All right, now we're going to try a new little thing here. I didn't know how this worked until 0 period. I created it, but I didn't know. I need 1 slate blue partnership for starters to volunteer. 1 slate blue. Okay, those 2 hands went up first. Come up to the board, please. Now, this is what's going to happen. They're going to be the first ones. I think I have 6 questions in here. Okay?
Oh,
they are going to get a question. Oh, 2. They are going to get a question. They are going to answer it. When they are done answering it, they're going to go tag another. Are you in a slate or a blue seat? Blue. He's going to go tag a blue person who's willing. So you better be willing. Everyone's willing. And you're going to go tag a slate person. So, first of all, slate and blue, who do you want to be? Oh, they're, whoa. Stop. Stop right now.
Yeah, there was a
Oh, was there a timer? I wasn't even paying attention.
Oh, come on, Miss.
Oh, stop.
Okay.
First.
Yeah, don't look at that. Okay, so pick your, you're going to have a chance to pick your racer. So pick who you want your racer to be. Okay. Okay, pick what you want to be. Okay, they are kitty, so don't be a kitty. And you are bunny. Hit check. Okay, so watch for the question. I think it comes up on your screen.
Wait, what?
Wait, there'll be a question in just a second. There'll be a question, and then you'll pick. Wait till you see your choices. Okay, now go pick somebody else. Go.
Why? There's D.
Go get somebody else.
Oh.
Hurry, they're gonna get another question. Do you see the questions on your screen at all?
No.
Oh, okay. So you gotta look at them up here. If a gland is hyper-secreting, once you pick, go. You want to be first. Hurry, pick somebody. Purple's winning.
Question was so small. Like 2 seconds out.
Pick your answer.
Yep, you're right.
Purple is still winning. Who is that? That's blue, right?
Yeah.
Slate.
Or yeah, that's one.
They get power boost if they're first to answer and they're correct. You get a power boost. Oh, kitty cat got it first. Are they right? Okay, one more. Good. Oh, and the answer was C.
It's not done.
Yeah, it's all done. Yay! Good job. Okay, so, all right, let's go over the answers. So, if you were faced with this question, endocrine system control, what's your answer?
D.
Yes.
Yeah, endocrine system is, hi, respond to me, is slower but more long lasting. I don't know why it's not moving. Okay. Oh, because we're frozen. Swedish meatballs. Okay, I'm just going to pause here for a minute.